Yeah, I think it was right here. Dude, this is what I'm talking about, Kevin. when I am reading articles, this is exactly the kind of shit that I want to see.
Best part of hacking when you can just, critical thing, right?
Oh,
Yeah.
dude. All right, Mr. Kevin Mizu, the master of DOMPurify. Thank you for gracing us with your presence here on CTBBPodcast.
It's a pleasure to be in there. I can't wait to speak about DOMPurify today.
Awesome, dude. You've been doing great work on the Critical Thinking Research Lab as well. It's been a pleasure to have you in there. And when I saw you write this stuff up and release it, I had the pleasure of pre-reading it. And as I was reading through, I was like trying to stay focused on like being a good proofreader and like trying to find, maybe we should reword this, reword that. But as I'm reading, I'm like, oh my God, that's really interesting. Oh my God. Oh man, I kept getting distracted by the content. So great work on this article, really. And, like I said in the chat, I wanted to devote a whole episode to this because DOMPurify is so widely used in so many different, applications. And what you wrote up here, don't get me wrong, Kevin, the first article was amazing, right? Absolutely amazing. But the second article is like, wow, this is so applicable for a bug bounty hunter because these misconfigurations are what bug bounty hunters live off of, right? That's where we live. So I was really excited to talk about both of them. But first, we gotta cut your teeth in the CTBB podcast world. We got to start off with a bug that you're really proud of. So what bug did you bring for us today?
So I think it's probably the bug that I'm the most proud of that I found recently. It's a client-side chain. So I will try to explain it a bit quickly, but I had a gadget which allows me to have an account takeover on the main application of a website. But it requires me to have control over cookies. So I need to find somehow a cookie injection or simply an XSS on a subdomain. And after looking a bit through all the subdomain of that website, I found one which had a get parameter, which was using in a fetch request. But this fetch request has to be same origin. So you still be limited by the feature which is present on the application itself. And the response of that fetch request was finishing in a document.writesync. So
okay, promising.
It's mostly an XSS as a feature. But the problem was that that application only have two routes, which was doing anything. I mean, there is no feature related to it except the XSS. And I have no file upload feature, no API, nothing that I can actually use to have a bug. So after playing a bit with it, I found that the application was hosted behind Cloudflare. And after playing a bit with the CDN CGI image endpoints, I found that application was actually having another domain which was historically used, and that specific domain was still allowed in the Cloudflare configuration.
Okay, that's great. How did you identify that? How did you find that?
Honestly, I was a bit lazy, and I took the top 100 websites or something like that, just a word list on internet. Try to fuzz all of them, and luckily I found one. But
no way! Wow, yeah, that's awesome. That's great.
It was really lucky, honestly. And when I found that domain, I saw that I was able to use not only the main domain of the historical one, but also all the subdomain related to it. And yes, thanks to this, I managed to find an hidden file upload feature, which allows me to use an image that I control on the CDN CGI endpoint. So in short, thanks to this, I was able to make a fetch request to CDN CGI, which returns me an image that I control, which contain into it in the EXIF an HTML payload. And then when it's get consumed by document.write, it the PNG get converted to HTML, which creates an XSS actually.
Wow. Okay. So I see that I'm looking at the doc right now. There's 14 bullet points under this bug. And we're about halfway through right now. So let me take a second to summarize. So correct me if I got any part of this wrong. Okay. So we find this gadget on a subdomain, and we go specifically looking for this gadget because we have a session fixation based ATO. We find this gadget on the subdomain that allows you to control the destination of a fetch request. And that fetch request's output is just dumped directly into document.write, but it has to be same origin. So there's no other paths on this. So we hit the CDN CGI image endpoint, which is a part of Cloudflare, which allows you to retrieve an image from a different server. But it's limited to just a specific set of domains, which you enumerated by brute forcing. And then you find a place in that domain where you can upload a file and put HTML data inside of the EXIF metadata for that file. And then you hit that via the fetch request and dump it into document.write.
Yeah.
Is that right?
Yep.
Oh
PNG to
God,
XSS.
dude. Oh my God. That's amazing. It's crazy to me that I'm sorry, I'm getting derailed, but it's crazy to me that the CDN CGI endpoint doesn't strip like that metadata or those or at least HTML tags. Like I feel like that would be a good security feature for them to implement. But if anybody from Cloudflare is listening to this, don't do that. Do not implement that. What do you think about that?
I think it's complicated because there is so many ways to hide like chars within an image, and those characters could be like legitimate. There is maybe some way that an image needs to have those tags within it. So
that's true. Yeah, or like SVGs as well, right? Like if they allow legitimate SVGs, you can't just like replace the left bracket or whatever, left angle bracket. Okay, all right. So then we hit that, but you run into a CSP, it seems, right?
Yep. So the CSP bypass wasn't really difficult, actually. I simply used an AngularJS gadget, and I was able to have the XSS.
Nice.
So it's not really the most important part of the bypass. But thanks to this XSS, which was on a completely useless domain, I was finally able to end that chain, which was, I think, very interesting in the end. So the login feature of the main website was using something interesting, which was when you go on the login page, you get redirected to a specific page which has in the link UUID v4, so you can't brute force it.
Okay.
And that UUID is associated with two cookies, one session cookies with which has a specific value, and another one which is prefixed with a _host dash, which has the same value.
Okay.
And the _host cookies is like not something that you want to see when you want to perform a session fixation, because you can't set it through JavaScript.
Right. That has to be, that's an HTTP only one, I think. Yeah.
And not only it's, I think it's a reserved prefix, so it absolutely can't be set from the JavaScript. Not at all.
Yeah, absolutely. Yeah.
And so to abuse that, I mean, there is something that I need to explain first, because if you have like two clients, which has the exact same configuration, like the same UUID, the same session cookies, and one of them authenticates on the application, then the first one or the second one just need to refresh the page to be authenticated as well. It was like a very interesting feature.
That's a weird bug. Yeah.
So the only thing that I was needing to do is finding a way to force the victim to have the same setup as I do. And to do that, I wasn't able to directly do session fixation because the session cookie was set for something like a year and has the priority over mine. But after playing a bit with the application, I've thought that if you go like on any path like /a with two session cookie with different value, then the application will detect that something wrong is actually happening. Maybe it detects that it is an attack actually, and it will try to remove the cookies on the top level domain because this is the only way for the browser to have two cookies in the same time. But the problem when you try to do that is that if you do a set cookie with an empty value, you need to have the exact a cookie configuration to remove it.
With the domain and the path, right?
Exactly. So if you try to remove the cookie on stage, but it has been set on stage A, it won't work at all. So to bypass this, the application was trying to guess the path on which it has been set. And to do that, it was simply taking the request URL provided by the user and putting it in the set cookie header.
Ah, okay.
So
okay.
what I was able to do is simply doing a session fixation, going on / semicolon domain equal semicolon. And that way I was able to force the application not to remove my cookie, but the one from the user.
Nice. That's amazing. That's so good. Very good. So now you've got your session fixated on there. And then
on the first cookie, but I was still needing to find a way to control the second one with the double underscore host cookie.
Right, with the prefix, because you can't set it from JavaScript.
But actually, this one wasn't too hard to set, because when you go on a login page with a valid UID link to a valid session value, if you don't provide the double underscore host cookie, the application will detect that something is going wrong, but it will suppose that you are doing something like legitimate. So you are trying to log in with the correct value. So it will say like, oh, you're missing that cookie. Let me set this cookie to the right value that you need.
Let me just help for you. Oh
exactly.
So helpful.
So I was just needing to do a post request cross sites with the session cookie with same site none, and that way everything was ready. I just need to wait the user to log into his account and refresh my page to get an account takeover.
Wow, very cool, man. That is an amazing bug. Lots of cookie quirks, crazy, creative, XSS. I love it, dude. I love it. You have established your authority now to speak on the CTBB podcast after that bug, for sure. I do have a question about it though, and this is just I can't pull it out of my head. I'm wondering if we could have done anything with cookie jar overflows here, where you could force that host cookie and force the original cookie out of the cookie jar, and then just fixate your stuff. Did you try that, or did it occur to you? Because I don't remember if underscore host can be affected by that attack.
I didn't, but for two reasons. Because first, I think that cookie jar overflow only works if you set cookies on the actual domain on which you want to do the attack.
You can't do that cross domain.
Yeah, I think.
Okay.
And the second reason is that since from a post request I was able to have like the exact configuration I was needing, I don't even try to do that.
Yeah. Okay, that makes sense. Yeah, I'm gonna have to research that because cookie jar overflow would be a little bit more helpful if we could just delete cookies. Like if I had an XSS on subdomain.site.com, if I could delete cookies for site.com, that would be pretty helpful with the cookie jar.
It will be amazing, but honestly, if you do manage to do that, I think it will be a Chromium 0 day. To be honest.
Oh, really? Oh, jeez. Okay.
Yes, because there's supposed to be some boundary between different sites, even if they are same sites. So I might be wrong, but
it's just interesting because like the reason the cookie jar overflow works is because you're pushing those cookies out of storage, right? So I don't understand how. I guess maybe the storage is segmented a little bit different by site. Perhaps that's what's going on. It's segmented by site. And even so, it can send more cookies than are in the cookie jar to the server, but it can't store those in that same site cookie jar. Okay. That makes sense. I'm going to validate that after this. All right. Very cool. So let's go ahead and jump into now we do things a little weird here on CTBB podcast. Okay. Now we're going to jump back. Kevin Mizu, I said your name. Who are you? What do you work for? What are you up to in life right now, man?
So currently I've finished my studies something like a year ago.
Okay.
I'm working in a small French company called BSecure, in which I'm doing mostly pen tests and web audits. And on my free time, I'm doing some research, some development, like on DOM Clobbering. And when I finally have some time, I'm doing Bamboo actually. But I prefer to focus on research and developing stuff.
Yeah, dude, it's been great to see your research come through, and I'm really excited for some of the stuff you're building from an automation perspective. Obviously, DOMLogger++ is a masterpiece, and I love it. But also, you've got some really cool sort of JS and headless browser-based automation you're working on right now.
Yep.
Which I'm excited to see come out soon. But Yeah, no, and to be honest, dude, that DOMPurify, or not DOMPurify, the DOM Logger plus masterclass that we did for the pod was like one of my favorite masterclasses we've ever done. That was just so fun and so insightful. So thank you so much for doing that. Now you're a guest in the masterclasses and a guest on the pod. So definitely excited for that. All right, let's go ahead and jump into the main topic for today, which is DOMPurify and its various misconfigurations and bypasses. Kevin did a 2-article series on DOMPurify and the research that he put into DOMPurify on his blog mizu.re, which if you haven't subscribed to, you should, and definitely go follow him on Twitter at Kevin_Mizu. And so these articles were broken out into two articles. The first one was mostly just focused on research and the DOMPurify bypasses that you worked on and that other people have worked on, sort of documenting the sort of state of the art as far as DOMPurify bypasses go. And then the second one was taking that research and then building upon it with misconfigurations and taking some of the knowledge from the research that was done in the beginning and applying those with misconfigurations to find ways to exploit DOMPurify in really hands-on production environments. And when I hit you up about this, I told you we're gonna do things a little weird. Like first we jump into the bug, then we go into the introduction, and we're gonna skip to the end to first talk about the DOMPurify misconfigurations. And the reason we're doing this is because listen, guys, I am a client-side guy. I love client-side stuff. I don't profess to be a particular expert in mutation XSS, right? Which is a lot of what this is. But that first article is dense, guys. And it is tricky to, don't get me wrong, Kevin, it is amazingly done, especially with the way you embedded all of the, DOM stuff into, what's the name of that thing from Yes We Hack that you...
DOM Explorer, which
DOM
has been developed by BitK.
I love that. It's so clean, but it's a little bit difficult to convey that via the audio medium to the listeners. So what we're going to do is we're going to hop into misconfigurations. We're going to talk about misconfigurations as much as we can until we start needing some of that requisite knowledge from the first article. Then we'll go back, hit that, and then we'll finish up the misconfigurations, which are most relevant to the bug hunters. Does that sound good? Am I crazy?
Yeah, perfect.
Okay. All right, cool. So let's do it. All right. So we're going to start with a little bit about DOMPurify. Correct me where I'm wrong on this, and then you can kind of take the explanation a little further. Yep. DOMPurify is an HTML sanitization library, the premier HTML sanitization library. And essentially what it allows you to do is take untrusted user input, sanitize it, and then put it into the DOM. And this should allow you, if the configurations in DOMPurify should allow you to do that without fear of XSS occurring from that HTML sanitization. And there's some questionable defaults, I think, in DOMPurify with style and with form and stuff like that. But by default, it should pretty much clean everything up. Do you have anything else you want to say on like what DOMPurify does and how it functions and what makes it unique as an HTML sanitizer?
Yeah, probably, because I think DOMPurify, as said, is very special because by default, Cure53, which is the company which has developed DOMPurify, try to provide not only a basic sanitizer, but one which allows by default as much stuff as they could allow. So
what a task, man. What a task.
Like they could have tried to simply put a sanitizer which only allows like H tag or I don't know, but actually they do allow the SVG namespace, the MATML namespace, the HTML namespace. And I think that this is probably one of the only HTML sanitizer that actually allows that.
It's crazy ambitious for them to do that, man. It really is. Yeah. So yeah, it's used all over the place. We see it everywhere. Very, very cool project that Cure53 put out. I have so much respect for those guys. Really, they do an amazing job. And one of the other things that makes DOMPurify unique is it can be run on the server side and the client side, right? Yep. So is it more common for us to see it on the server side? Is it more common for us to see it on the client side? When you're approaching DOMPurify from a research perspective and also as a bug bounty hunter, what have you seen? What's your experience with that been?
Actually, most of the time, I think it's being used on the client side. I did try to see some statistics like on NPM, the number of weekly downloads and like on CDNs. But actually, if you look at npm, it's represent both client-side and server-side usage. And on CDN, you can't really have the number of applications that are currently using it because you will just have the number of individual connection.
Yeah.
But
800 million monthly HTTP
that's
requests.
a lot.
Holy
that's
crap.
Insane.
That's insane.
But
yeah,
since DOMPurify can only be used on a JavaScript backend, I think that's probably mostly being used on the client side.
Yeah, that makes sense. Dude, let me just say to the listeners as well, like perhaps for you guys as you're listening wherever you are, whatever you're doing, it just sounds like a good episode, right? You listen to the episode, you're like, wow, that's a great episode. This episode is so well prepared. Kevin, thank you for going into the doc here and do it. Like I just threw a question in there. I said, more common, server side or client side? And he like breaks down, grabs all the CDN statistics, the NPM statistics, like the prep that went into this is amazing. So thank you for doing that, Kevin. I have to shout you out.
Thank you.
Okay, awesome. So we're dealing with it mostly on the client side. So what we might expect to see with that, let's say for example, let's say it's a stored XSS. We send some HTML to the server side. It's stored in that format, and then it comes back to the client side, maybe as the result of a fetch request, and we see the valid, XSS payload in the response from the server. But then by the time it hits the DOM, it's sanitized, right? And that's like a classic scenario where you'd be like, okay, yeah, there's some sanitization happening at the client side level. Okay, I see where we're at there. So I guess, man, there's so many ways that we could go with this, right? Because one of the things that I want to ask you about is like, okay, let's talk about the server side for a second, because it's so much more impactful if we can get an XSS on the server side, right? Like if you can get an XSS on like a headless browser that's like generating an invoice or something like that, a lot of times you have a route to SSRF and RCE. So let me ask you this. If you're in a blind scenario where it's just generating a PDF and you can see the output physically, right? But you can't actually inspect the DOM. How do I fingerprint whether it's DOMPurify or not? Is that like, I don't know if that's like a crazy hard question or not, but does anything come to your mind?
Not really. Actually, there is a trick for that that I've used several times in Bug Bounty. If you do have like an HTML injection in a PDF and you don't know really what happened with your inputs, you can just use the plain text tag, which is a deprecated tag, which is going to convert the end of the DOM as raw text. So that way you will be able to see like the text version of your HTML inputs. And like that's why you will be able to see what is going to be sanitized, what is going to be replaced. And I've seen a lot of time like very bad sanitizer being used in that context. And simply by being able to see what's happened, you see like, what the fuck, there is an A replace it there. And you just need like to update your payload to have something working.
Wait. So does, let's say it is DOMPurify, will the plain text tag make it through DOMPurify, or is it in a different environment?
It depends, because if your PDF is generated, for example, with an headless browser, then DOMPurify is going to be used before the input being inserted into the DOM. So what you are going to see is the sanitized version of the inputs, but this time in text. So then you can like play with the text output version of DOMPurify to see if there is some patterns that might fit DOMPurify, or I don't know, another sanitizer.
Dude,
to then start playing with it.
That's a great tip. Okay, very cool. And then when we're fingerprinting DOMPurify on the client side, I see you've got another trick here in the doc relating to the CID aspect of the href. Can you tell me about that?
I might be wrong, but I think that DOMPurify is one of the only sanitizer that allows by default the CID schema in the href tag, href attribute, I think.
Okay.
But honestly, if you want to see if it is DOMPurify on the client side, there is so many ways to
you can just
simply check into the sources.
And control F for DOMPurify. It's not ever like, you haven't run into anything where it's obfuscated or anything like that before. Okay, cool. So it should be pretty easy on the client side. You just control F for it. Boom. If you're dealing with something, where you can inspect the href, we can use CID if it's like server side, or if it's client side, and then you don't feel like using your sources tab, I guess. Okay, cool. So that makes sense. Now let's go into a little bit of the misconfiguration that we sort of talked about now that we've kind of set the tone. So one of the things that you said moving into this second article was that you sort of ended the first article with, okay, now DOMPurify security solely relies on one regex being executed correctly. What is that regex, and like why is that regex so important to DOMPurify's security?
Actually, I will try to explain it without needing to explain everything that has been covered in the first article. But in short, when you want to do mutation XSS, most of the time you will hide the payload within an attribute value. So we'll need to use something like a comment closure, or maybe a style or a title closure tag. And those are like mandatory if you want to do a mutation XSS.
Because those are different contexts on the inside of those tags. Is that the reason for that?
More
you
or less,
can't have
yes.
HTML tags inside those?
Actually, you do can, but it's like when you are using an HTML sanitizer, you have like two parsing. So the first one is what DOMPurify is going to see, and the second is what the DOM is going to receive.
Right.
And when you are going to do mutation XSS, you want to have a different context between the browser and DOMPurify. And the goal in the end is to have a context which is going to break an HTML attributes and create the XSS. So one way of fixing it is to limit the attribute value. And I think it's a good way actually, but it's still like not perfectly limited, because if you find a way to bypass that regex in the end, the mutation is still present.
Okay. So what you're saying there is that a lot of times the flow, the strategy that we use to get these mutation XSS is we put HTML tags inside of the attribute, right? Because we can use those characters, the angle brackets, that sort of thing, inside of the HTML attribute. And then what we try to cause with the mutation is that attribute moving from an attribute state to an actual HTML processing state. And then that's where the mismatch occurs. Is that accurate?
Exactly.
Okay, perfect. And so what DOMPurify did, and I did kind of give you an impossible mission here. I'm like, explain the regex without explaining the first part. So, great answer. That makes sense. And the reason why that's so important, just trying to quickly summarize that first part, is that there's a pretty well-documented way to bypass DOMPurify if you are able to smuggle HTML tags inside of that regex, right? The regex that they implemented is simply to remove all HTML-like tags, or maybe just a set of HTML-like tags from the attribute?
Not exactly, because Core 53 still want to have something which doesn't limit the developer at all. So that's why they haven't implemented that regex before, while there is a lot of research that have already been made in the past. So they decided to only limit to style, title, and comments tags, which are being used in mutation XSS. So you still can use like image tag in an attribute. You won't be limited. But if you try to do something malicious, it won't work.
These guys are legends, man. They really, really do try to go for the minimum, secure, maximum secure, but with the minimum restrictions that you can possibly have. Super cool. Okay, so we've got no HTML comments, no title, no style in our HTML attributes. And if we can figure out a way to not make that regex hit, then we are good to go to trigger that mutation XSS.
I just need to charge my computer. Excuse me.
Oh, you're good. We can cut, or we can not cut. We'll see. It's fine. This pod is very chill.
Okay, perfect.
Oh, you're good. Yeah. Okay, cool. So that makes sense. Now let's move to the misconfigurations. And some of these misconfigurations are like clear as day, and other ones utilize this like regex bypass to cause the mutation and do trigger the XSS. So first one on the list, dangerous tags, dangerous allow lists. Tell me a little bit about that.
Well, DOMPurify aims also to provide a lot of ways to be configured to a web developer. So when you are using it, you can like modify which tags are being allowed and which tag you want to add to the default allow list. So those are commonly used, but most of the time you won't see any dangerous tag because obviously the developer won't allow like a script tag. But sometimes, who knows, maybe they could be used in a way that they shouldn't be used. So we have the list on the doc. Maybe you want me to cite them.
Yeah. Let me go ahead and share my screen as well. I probably should be sharing my screen. Sorry, Christian. My video editor is always like, dude, just share your screen so we can give these people some visuals. Okay, let me jump to this. Yeah. So what have we got here in the what is the default allow list here?
I could give you the link, but it's present on the DOMPurify source code.
Okay, gotcha. So the default allow list is pretty liberal. Let's see.
Yeah. Almost every HTML tag are being allowed, like except maybe script, no script, iframe, or dangerous stuff like that. But
right. Okay. And so we have these several configuration settings that are passed into DOMPurify: allowed tags, allowed attributes, add tags, add attributes. Okay. So if we're using allowed tags or allowed attributes, we are overriding the default list and allowing only these specific tags. So you're sort of limiting the amount of tags that are there.
Yep.
On the other hand, if we're using add tags or add attributes, then that's adding it to the already default allowed list and making the policy a little bit more lax. Is that accurate?
Exactly.
Okay. Cool. And I think, I don't know, now that I'm in here, I'm remembering it. But yeah, I think it was right here. Dude, this is what I'm talking about, Kevin. when I am reading articles, this is exactly the kind of shit that I want to see. Okay. So in the beginning of this article, I should have put this before we started in the misconfigurations. He says, hey guys, here is what you should do if you're ever looking at a DOMPurify misconfiguration. And he gives you a string to search for that will just take you directly to the beginning of the sanitize function in DOMPurify. And that sanitize function, if you just inspect that sanitize function, you can easily grab out the configuration values that are being passed into DOMPurify. And then like that is just such a valuable tip. Okay. Like it's just amazing because it creates an easy entry point. You don't have to jump through all the code. You're always going to go to the same spot. If it's DOMPurify, you're going to set a breakpoint or a log point right at the beginning of that sanitize function. And then you inspect the configuration values and look for any of these misconfigurations that we're talking about further down in the article. So awesome stuff there. Obviously, the ways you can shoot yourself in the foot with the dangerous allow lists would be like allowing something like script or like onload or anything like that for the attributes. Is there anything else sort of that we should be on the lookout for with these allow tags, allow attributes configurations?
I don't think so, because anyway, even if you allow tag, it will be sanitized by DOMPurify in the end. So it needs to be a tag that have a direct impact with the DOM, like iframe source doc or something like that.
Okay, solid. Yeah, that makes sense. Okay, and then later down in that same section, you're talking about the default setting for DOMPurify, which is pretty liberal, like we talked about, is allow data attributes and allow ARIA attributes. So essentially, you can set any attribute as long as it starts with data equals or ARIA equals. Why are they doing that, and why is that important to know for bypassing DOMPurify?
I think why they are doing it is like everything that they are doing with DOMPurify, they want to have something flexible. And why this is important in the context of bug bounty? Well, there is an example after this snippet, but there is a lot of HTML gadgets which can be found like with UGS, which is present on Ruby framework by default, I think.
Yeah, by default on Ruby, yeah.
And yeah, a lot of data attributes can be abused to like hijack some JavaScript flows and trigger an XSS, which DOMPurify won't be able to see.
Yeah, the data attributes, I think I've seen this a couple times. I think it was with Johan Carlson doing some research that one of the best ways to bypass in a highly CSP'd environment, I think we actually talked about it when he came on the pod, is these sort of gadgets, right? Where it's like, okay, I can't run script, unsafe inline or anything like that, but I can, add something to the DOM with a specific data attribute or whatever. And there's some observer sort of watching the DOM and saying, okay, when this gets added, we're going to trigger some code, right? And then it just becomes a gadget hunting where you're like, okay, what can I add to the DOM that changes the state of the DOM, that changes the state of my specific tag, that triggers some code that accomplishes a malicious purpose. And I think if I remember correctly, DOM Logger++ is one of the best ways to sort of find these gadgets, right? So like, have you because you can hook after something's been added to the DOM in particular, right? Can you talk a little bit about that?
I've made a configuration which should be available on the GitHub, which basically aims to start logging everything which is happening after a specific event have been triggered within the DOM. So it could be like you start logging when your inputs reach the documents, and that way you will be sure that you won't have any false positive when you are auditing some codes.
So you say, okay, there's going to be a tag. There's going to be an A tag with the data dash Justin is checking something, ID. And then we hook that into DOM Logger++. And then everything, as soon as that element hits the DOM, then DOM Logger will start going, brrr, and you like how my brain thinks about this stuff. And then DOM Logger is going to go, brrr. And then DOM Logger will start logging everything. And then we'll be able to see what is happening after that hits the DOM, so we can find those gadgets. Okay, cool.
There is also something which could be interesting to look for the auditors, which is the JavaScript event delegation.
What is that?
So basically, there is several ways to create an event in JavaScript. One way is simply to put the event on a specific tag, like the onClick events. But another way, which is exactly what UGS is actually doing under the hood, is you will put the onClick event on the documents, and at the time you click on the body, you will check all the event.target nodes and check if one of those nodes have a specific attribute or whatever. And the main difference with the first way to set an event is that you can have like an HTML injection which occurs after the event has been created. Because anyway, the event is present on the documents, but when you are going to click on the node in the end, it will simply check if it has the property that you want him to have to trigger the events.
So I guess maybe is this what's happening when I'm not sure if I tracked with that, but I'll try. Is this what's happening when I'm like, oh, okay, I've got like this button. I want to see what happens when I click this button. So I like go into DevTools and I click on it, and then I go to like events and stuff like that, and I try to find the click event, and then there's nothing there. Right?
Yeah, probably.
What's happening is the click event is actually happening at a higher level, and then it's saying, okay, what's the target of that event? Oh, it's this button. Now I'm going to register that callback. Is that, dude? I've always wondered why that was happening. I'm like, how are they triggering something if there's no on-click event? That makes sense though.
Yeah, because when you click on the page, it's going to trigger the event on all the elements that are related to that action. So putting the event on the document works, and this is why you are able to abuse the UGS gadget, actually, because when the page loads, UGS is probably one of the first thing which is actually being executed. But even if your HTML injection happened at the end, you still be able to abuse it because this is how actually the event is being used.
Dude, that is really helpful. That is so helpful, Kevin. Dude, this episode is already amazing. I'm hyped. I learned so much stuff already. Okay. Any final comments on this dangerous allow list section of the misconfigurations?
I don't think so.
Okay. Let's move on to the next one then. Dangerous URI attribute configuration. And when I saw this, dude, I was like, hell yeah, a regex. Like this is what we love to see as hackers. It's like, wow, if there's a regex, people always mess that up. And it's interesting too, because I don't know if this was intentional or not, but like the allowed URI regex that you put in the thing, it has the unescaped dot there, and whenever I see a dot without a backslash in it, I'm like triggered. Obviously it doesn't have the caret or the dollar sign as well, which is what you exploited here. But it's whenever I look at this regex, which for anybody who's listening on audio only, is literally just a domain. Mizu.re, which is where his blog is hosted, but the dot isn't escaped. My brain just goes triggered, exploit that. So what is this allowed URI regex configuration that can get passed into DOMPurify?
I'm not sure to understand the question, but it allows you to simply overwrite which links can be used in DOMPurify. So basically, by default, DOMPurify has a pretty strong regex, but sometimes you might have something a bit more custom. I've seen it on several websites. And yeah, I don't think that developers understand that they are overwriting the default value, and they might be forgetting the dollar at the beginning, at the end, I think.
The dollar at the end.
Yeah, there is a lot of ways to abuse it, actually.
Okay, so what this does is it overrides the URL regex, which is pretty strict, although it does include the CID thing that we mentioned before. That's default to DOMPurify whenever it's put in like an href or something like that. And the example that we have here is they just provided you just provided your domain, which I could totally see happening, right? They could be like, oh, I just popped my headphone cord out. But I could totally see that happening, right? Where it's like, I only want this to be able to point specifically towards my domain, no other links to any other sites on this, in this specific setup. But what they forget is that this is a holistic regex. So it needs to have the dollar or the caret at the beginning, the little upward arrow, and the dollar sign at the end in order to match that whole flow. So what you did to exploit that was you put JavaScript :alert1, and then you just commented out the rest of the line, and then put in the value that they wanted to see, and that matches the regex, which allowed you to pass through a malicious href into your A tag. That makes sense. And then is this regex only for the A href attribute, or is this used in other places as well?
No, it's for every URI attributes. So the href attribute of the use tag is going to be involved as well. The form action, I think.
But
really? Yeah, every attribute that needs to have a URI are going to be impacted.
Okay, very cool. And then what is this add URI safe attribute setting?
It's mostly the same. Honestly, I never saw this being used somewhere, but it was important to be mentioned. So this option allows you to say, hey, that specific attribute is not safe, and you don't need to check it anymore.
Oh, okay. So it's
basically
just don't worry about it. We got it.
Yeah, exactly.
Wow.
You just downgrade the sanitization in some place, actually.
That's an easy one to look out for, and all of these will be present in that sanitize function when we put that breakpoint, at the beginning of the sanitize function. Dude, this is easy, man. You make it too easy, Kevin. One of the things we talked about on the pod before, and I even shouted you out for this, was that there are a lot of hackers that have done this really cool thing where they have become the go-to person for one thing, right? Classic example of that is Alex Chapman, who is the go-to guy for anything headless browser, right? And I think you've done the same thing for DOMPurify. If I've got a DOMPurify scenario, I'm just like, yep, it's going to go to Kevin right now. But now, Kevin, I can just load up Mizu.re and look at this methodology, and you made it too easy to know how to bypass DOMPurify. But really do appreciate the contribution to the community. Okay. So let's go to this next one.
I think there is something important to be mentioned because since the beginning we are saying that you can easily retrieve the option passed to document.sanitize call. But it's important to remind that each time DOMPurify is being used, it might have a different configuration. Like I've seen it a lot of time. We even abused this once with Matemba on a bug, but it's not because you see a specific configuration that is safe that the next call will be safe as well.
So it would be interesting then to be able to do like a DOM logger ++ hook at that sanitize function. And I told you that before, and you told me some problem with that, and I can't remember what it was. what was that problem?
Actually, there is some way to hook the sanitize function. Like you can hook for a DOM parser prototype parse from string, which is used to parse the HTML in the end. So you will be able to see when your HTML input is being parsed. But if you want to retrieve the configuration, the problem is that DOMPurify could be initialized anywhere within the JavaScript. And actually, it's almost impossible to retrieve a local variable which is used somewhere you don't have information about.
Yeah, that's interesting because like even if we did something like, okay, one of the first lines, I think, this is how you find the sanitize thing, is like doing a string replace. Even if we override the string replace function to do something that we're going to do, you can't jump up that extra call in the stack to go into to get access to the local variables in the DOM logger ++ sanitization, or the DOMPurify sanitization function. Okay, yeah, that's tricky. Okay, so you kind of have to do it a little bit manually each time.
You can simply use a log point at the beginning of the sanitize function and just look into your DevTools if there is any configuration that are being used, which are dangerous.
Yeah, that makes sense. Okay, cool. Let's jump into this next one. Bad usage, not enough context. As I understand this is not using DOMPurify how it's intended to be used. And essentially it's adding some like text area or some NoScript style XMP. You listed a bunch of tags here that could affect how DOMPurify will be able to effectively sanitize the user input before, after, appending that after the sanitization already occurs. Is that accurate? And what have you seen this often? This seems like this would be really, really common.
Honestly, I've seen it in CTF challenge. But I still believe that having sanitized inputs which finish in a title tag might be possible. Just people absolutely don't look into the title tag because they assume that it is safe most of the time, I think. But yeah, the problem is that when you're using DOMPurify, mostly on the server side, you will provide him only parts of the body as a context. So you will like sanitize the user inputs, but that user input is going to finish somewhere within the page. And when the server respawns to the browser with the whole page, that time the browser will parse everything at once. And yeah, if you put like the output of DOMPurify of something into something dangerous, then you might break everything.
Okay. So the reason why this is bad in the specific scenario is the code that you gave here was that it sanitizes the user's input and then places it inside a text area tag. And a text area tag prevents the actual content inside of it from being parsed as a HTML tag up until the closed text area tag. So it's considered to be plain text. So then what we do, we pass in a div that has the ID or whatever other approved attribute of closed text area, and then whatever our XSS payload is, that will be permitted inside the attribute because they've got to be super permissive with their attributes.
Exactly. Actually, this since 3.1.3, it doesn't work anymore with style and title, as we have said at the beginning. But they still have decided to leave text area scripts and also tag being allowed in an attribute because they do want to have something which don't limit the developer in the end. Wow.
Yeah, that's amazing. So then when it is added to the DOM with the text area, the div tag, which we previously had, it is just plain text. It's not a tag. So the ID attribute isn't being processed up until the closed text area, and then our image tag that precedes that directly is being parsed as HTML, and that's why the bypass works. Okay, cool. So the TLDR of all that is look at where your specific sanitized output is being placed and try to manipulate the payload that's going through DOMPurify. I keep on wanting to say DOM logger because why are they so similar, Kevin? The payload that's going through DOMPurify to actually fit that context that it's in, that may allow for some additional bypasses. Okay, solid. Anything else that the user should know about in this specific session? I see some stuff with JSON here.
This one is a bit more specific, but it's not working anymore on the latest version. It was a bug that I did found in Bug Bounty, but I think it's still interesting. It was a case where DOMPurify was used twice in a row with a user input. And
okay,
what
two
you
user
could,
inputs right next to each other. I feel like that should be pretty common. Yeah.
Exactly. And what you can do in such specific version is, thanks to the first HTML injection, you hijack the document getElementById to this time put an HVG tag. So now the second DOMPurify Sanitize is going to be used not in the HTML namespace, but within the HVG namespace. And thanks to that, before DOMPurify 3.1.2, you was able to simply bypass it. Just because it was using it twice.
So it's a little bit of like, it's not necessarily DOM clobbering, but it's like a little bit of like a query selector or a getElementById selector hijacking in the page. So, okay, if there's multiple calls to DOMPurify and you're able to hijack one of those calls, then that may allow you to swap the namespaces and trigger the XSS. Okay. Dude, little side tangent. I love query selector and getElementById selector hijacking. That is just such an interesting bug class, and you can trigger so many interesting pieces of functionality with that. It's crazy. It really is. All right, let's jump down into this next one. Okay, so we've got bad usage replacing the output. Yeah, dude, this is a really cool one, and I think this is one that sort of applies to security in general, right? If you do sanitization and then after that sanitization you modify it in some way, right, further, then that really can affect the integrity of the sanitization. So tell us a little bit about the bad usage and replacing the output misconfiguration.
Actually, there is two examples. So in that section, the first one is related to an old CVE, which have been found in 2020. So shortly, jQuery in oldest version was doing some kind of specific replacements in the HTML function to make it like compatible with the old XHTML parsing. So they was making replacements with the slash and greater than to force the tag from being closed. And so when Masato found that, Core 53 decided to fix it and to put some very strict rules about that to ensure that DOMPurify can't be bypassed because of that issue, because jQuery was used almost everywhere also. And the fact is, since a lot of protection have been added in DOMPurify since 2020, they decided something like a year ago to remove that protection. And now, thanks to the recent bypasses, if the application is using jQuery with an older version, which is still vulnerable to that issue, then it's possible to use the recent DOMPurify bypasses research to bypass DOMPurify again.
Wow. Okay. So if I'm looking at this correctly, it says by default, since that version, the filter is deactivated. So you are able to use this alternative close tag. Is that right?
Exactly.
Okay.
You should be able to see in the snippets that I'm using a style slash instead of slash style.
Right here. Okay.
Yeah, which is going to be replaced automatically by the vulnerable version of jQuery.
Wow. Okay. Gotcha. So that is going to be replaced with jQuery to the actual close tag. And that also sort of affects that regex that we were talking about in the beginning. It's all coming, dude. You know, I'm not gonna lie. Sometimes I go into these episodes and I'm like, man, I've read this, I understand it, but like putting it into words is so hard. And now I'm starting to see it. So then, you know, what happens here is jQuery is providing a sort of a replace, right? Where you're putting in style slash.
Yeah.
Let me be very, very clear. Left angle bracket, style slash right angle bracket, right? And so it's not a valid close tag, but in jQuery, it's providing a replacement, and we use that replacement to bypass the regex that is validating, is there a close style tag in the HTML attribute? is that right?
Exactly.
Dude.
That's it.
Dude. Thank you for validating me, Kevin. I feel like this half of this episode has been you saying something and then me being like, wow, when Kevin says it, I understand it. And then I repeat it back to you. And when you tell me, yes, that's right, my heart is so happy. Okay, so that's great. So jQuery is doing a mutation on this, which makes sense. What is this other mutation that happens next?
Well, on the jQuery issue, this is something that you probably won't be able to see today since the version is 5 years old now.
Okay.
But the concept is very important. Like, if there is any library or anything that happens after, which do a replacement or a normalization like to uppercase, which we are going to see a bit later, then you should be able to bypass DOMPurify. And this is exactly what Masato have done a second time with TinyMCR, which is the second issue. So before a specific version, TinyMCR was replacing after DOMPurify the BOM character by an empty string. And because of that, you can simply hide a payload within a style tag or like in latest version to bypass the regex and have the payload working again.
Okay. So TinyMCR was doing a replacement. I'm looking at this on the Unicode code point FEFF. That's byte order mark. Is that what that is?
Yeah.
What is it? Okay, cool. And then, okay, dude, this is so crazy. So then you put that right in front of the style close. Dude, everything just manipulates this style close thing. That's so hilarious. Okay, yeah, and then that bypasses the regex, the all important regex that prevents the closed style tag from being inside of an attribute, which then breaks.
Actually, this is very interesting because something that people need to keep in mind is that DOMPurify is like used everywhere. So on one website, it might be possible to have two DOMPurify version because imagine that you are using TinyMCR. So TinyMCR has its own DOMPurify version, and then you are using your own DOMPurify version because you aren't using the one of TinyMCR. And this is more or less what I did try to explain in the second example, because I found a case in Bug Bounty where it is the second one with on top of it.
Oh, here?
That one, yes.
This one, yeah. Okay, I see.
I faced a situation in Bug Bounty where TinyMCR was using an up-to-date version of DOMPurify, but thanks to the replacement, I was able to bypass it. But then the website to fix that issue was using this time an outdated version of DOMPurify. But so the fact is that you can like bypass DOMPurify map even if it's used several times in a row. And more interestingly, I faced the case where there is two DOMPurifys used in a row, but this replacement was used twice as well. The problem is like you can't put like, for example, a new line within a new line. So at the first replacement, you already lose your gadgets to bypass the second DOMPurify. But you can use the fact that the DOM decodes by default HTML entities to hide from the first replacement the new line, which is going to appear after the first DOMPurify sanitizing, which then going to create the right replacement to bypass DOMPurify a second time.
Dude, that is amazing. And that makes total sense. So, you can't split a new line. Like a lot of times I think of a new line character as \n because I like, that's how I've always seen it, and I was like, oh, you could just do backslash but that doesn't work, you know, like, and so it's just such a, for a second, your brain's like, wait a second, no, that's not right. But yeah, absolutely, using some sort of encoding here to sort of space that out. That's genius. I love that. And using the auto decoding of HTML entities. Very cool, man. Okay, so now that sort of, and you listed a bunch of other examples on how DOMPurify has been bypassed and with other, you know, misconfigurations or bypasses. But that sort of concludes the first section, which is the misconfigurations that you commonly see. And now we move into DOMPurify Hooks, which is a little bit of a newer feature to DOMPurify, and it allows, if I understand correctly, and it allows the developer to hook into the sanitization process at various points. And when there's more configuration like this, there's more problems. So can you tell us a little bit about those hooks and where they can be used to bypass stuff?
Yes. So those are present within DOMPurify since a long time.
Okay. So they're not new.
But the fact is that in the context of sanitization configuration, it will be applied for one DOMPurify.sanitize call. At the opposite, DOMPurify hooks are defined to configure DOMPurify more globally. So they will be present each time you do a sanitization with that DOMPurify instance.
Okay.
And because of that, there is like no direct way to find those hooks except by searching within the JavaScript files. And I think that's one of the reasons why people probably haven't looked at them a lot since today, because you have to know that they exist, actually.
And you have to search for them directly because they're not going to be in that sanitize call. Okay.
So there is many hooks, but shortly, what you need to keep in mind is that all the time you have 3 hooks for the sanitize element timing, 3 hooks for the SanitizeAttribute timing, and 3 hooks for the sanitize shadow DOM timing.
Shadow
and each
DOM.
time,
I'm sorry. Every time I hear that in my brain, I'm just like, and then the shadow DOM. Like that's hilarious. I'm sorry. Okay, so 3 hooks for element sanitization, 3 hooks for attribute sanitization, 3 hooks for shadow DOM sanitization.
Yeah.
Okay. Before, upon, and after.
Exactly.
Okay. And so these hooks allow you to change the current configuration, the settings, manipulate the things being sanitized as they go through that specific flow. And help me understand how DOMPurify does the sanitization. Is it like starting with the top node and then like going down to the first child, and then does it go all the way through that whole chain and then work its way back up, or what does that flow look like?
If we go directly into the technical details, it uses first DOM parser, which is an API provided by the browsers to parse HTML.
Okay.
Thanks to this, it will obtain a tree, and it will retrieve by default only the body. This is something I abuse later in the article, but it retrieves only the body. And then it's going to use the node iterator API, which allows to create something on which you can do a for loop. And you will simply like iterate over each node of the tree, but it takes the node on the top of the tree and iterates down the tree to finish with the one at the bottom.
Okay, so does it start sanitizing at the innermost node, or does it start sanitizing at the top node?
Top node.
At the top node. Okay, so it sanitizes, goes to the child. Sanitizes,
Exactly.
goes to the child. Okay, gotcha. And it does that recursively. Dude, actually, it makes a lot of sense. When you said it just takes the body, I know you used that later to with the base tag. That was such an amazing misconfiguration. But that also makes me understand why the meta tag bug works. Do you know what I'm talking about? Where you can set like a meta tag refer policy. Have you seen that?
Yes.
Yeah. So J-Rock mentioned that on his episode. I'll have to go back and find the episode number. Maybe the production team can put it on the screen if they want to. But essentially what happens is you can pass a meta tag into DOMPurify, and that meta tag will get stripped out, right? For sure. But the effect that it has on the DOM is still present somehow. And I don't, as I'm saying it, I was like, oh, that makes sense because it's being passed in the DOM parser. But when you apply a meta tag to the DOM parser, then it applies it to the main DOM. Now it's not making sense again. Do you understand?
I'm not sure, but
okay.
Actually, it shouldn't be applied on the main DOM, but
maybe that isn't the place where it's triggered then.
But it should be applied within the DOM which is created by a DOM parser. And I'm not really surprised to hear that it do work in the context of DOMPurify or any DOM parser API, because when you are using DOM parser, you simply create a DOM the same way the browser will do when you receive an HTTP request. Like, it's exactly the same. And this is why most of the time you want to use a sanitizer on the client side, because you are going to use the same parser at the beginning and at the end of the input usage. So, yeah, I'm not really surprised. And the other point, as I was saying about the body, is that if you put the meta tag at the very beginning, DOMPurify won't be able to see it at all, because by default, when you pass an HTML input and you have like a style tag or a meta tag at the beginning, it will be placed in the head tag, which isn't retrieved and sanitized by DOMPurify, but will have an effect on all the nodes that are present after.
Dude, that's pretty hacked up, to be honest, that they only look at the body, that they don't consider what is in the head. I bet there's more bypasses that could be done there, because you can manipulate what I mean, obviously there is, because you did it with the base tag. All right, let's keep going. We'll have time for that, but let's keep going through what you have, and then I'll geek out about that later. Okay, so the first section that you had here was the upon sanitize attribute. So I'm sorry, let me just refresh my memory on the order. So it goes sanitize element, sanitize attribute, sanitize shadow DOM. Can you give me like a 2-second description of what sanitize shadow DOM does?
Or
is that not a 2-second description?
No, it should be fine. Like, if you go within the DOMPurify source code, it's like there is it won't be 2 seconds, honestly. But there is something really important to know. Like, when you are using the node iterator API, there is something which isn't handled by default by the browser. Is that when you iterate a DOM, when it reaches a shadow DOM, it won't go through the shadow DOM. So basically, if you create a sanitizer which only used the node iterator API, like, you will miss a lot of tags and there will be a lot of bypass just because of that.
Because they'll be hidden in the shadow DOM. Okay.
That's it. So DOMPurify is simply like taking the shadow DOM, creating a new iterator function out of it. And at the beginning and at the end of that new function, they are putting some hooks to help developers to do some stuff.
Okay, gotcha. So the flow is sanitize elements, sanitize attribute. If it's a shadow DOM, sanitize the shadow DOM. Is that right?
That's it.
Okay, cool. So then we talking about the first configuration. It's the upon sanitize attribute. So this is while the attribute is being sanitized itself. And you say that there's a misconfiguration there with the force keep attribute. Can you tell us about that?
Well, I think that this specific hooks is probably one of the most used hooks in DOMPurify, because this is the only one that allows a developer to have both a node and a reference to a specific attribute within the sanitization. And the funny stuff that was present in DOMPurify 3.1.3 up to 3.1.5 is that when they implemented the regex, they putted the regex after the force keep attributes value, which was being used by that specific hook.
Okay.
So in short, developers was able to say to DOMPurify, hey, that specific attribute is completely safe. I want you to do not sanitize it. And right after, DOMPurify was simply skipping it, but the regex check wasn't be made at all. So if there was any attribute which was allowed by default by the developer, thanks to that hook, you was able to bypass DOMPurify on source version.
Okay. So force keep attribute, I wonder if that's a little bit of a misnomer, because or if the name is a little bit weird, because what I would think if it was force keep attribute was do not remove this attribute. doesn't necessarily mean do not sanitize it at all. Like, does it mean do not sanitize it at all?
It's more do not sanitize it at all.
Wow. Yep. Okay. Gotcha. Yeah. So that even just the naming convention on that is a little bit unsure about that. And I would imagine that, like even if you wanted to say, for these specific data attributes or something like that, I need the specific data attribute to go through, and a user can control even a part of that. You say, okay, force this attribute to stay there. And then that skips the whole regex, which once again breaks all of DOMPurify. Okay, so we should be on the lookout for any use of force keep attribute.
But it has to be on specific version, because this is something I've reported to Cure53. So now it's fixed on the latest.
Why? Why did you? No.
I mean, it's important.
It is very important. I just, my first instinct is, damn it, Kevin, why? But then my second instinct is like, no, Justin, secure the internet. Okay, cool. So that works well.
The example on Draw.io, I think it's a great one, which helps to understand why do a developer will have to use that. It's a bit on the bottom.
Is it further down here?
Yeah, that one on the snippet on the bottom of your screen.
This one right here?
Yeah.
Okay, cool.
I think this is a great example because when you do want to sanitize for HVG contents, or I don't know, for example, the use tag with the href attributes, you might want to put some very specific sanitization process on those because they are like special, and you know that bad things can happen because of that. So you don't want to simply allow the use href elements. So sometimes web developers could want to use hooks to put a more specific logic to handle it in the way they want to handle it. And this is where Draw.io was vulnerable in the snippet present in the screen. They were simply like making sure that DOMPurify do not sanitize the content attributes. And because of that, it was possible to bypass it.
Yeah, man. So literally the condition is if force keep attribute is there, and you control arbitrarily even a part of the content of that attribute, just those two conditions,
it's
definitely
enough.
bypass. Dude, I love that. And I also love that you said this upon sanitize attribute is like one of the ones that's used the most, right? Like that is the kind of shit that you need to hear from like an expert that's like, yeah, I think that's the one that, that's the one we pay attention to, that we're really like, if there's one that you walk away from and you actually store in your hacker brain rather than having to reference back to the article, then it might be upon sanitize attribute. That's really good. I also love how you just casually dropped the Draw.io 0 day here. That's great.
Actually, it's not really a 0 day because this is something I've reported to Draw.io. And
damn it,
has
Kevin.
been fixed a year ago.
No, you're no, that's great. All right. Let's move to this next one. Once again, another upon sanitize attribute bypass. And this one occurs when you're using current node.set attribute. So essentially you're adding attributes to the attribute to the element that have already been is being sanitized.
This one is, I think, way more interesting than the previous one because this is something Cure53 can't fix at all. So it still works in the latest version. But in short, when DOMPurify sanitize an attributes, it will like take the node, retrieve the attribute, then it will iterate over each attribute present within it, and then it's going to like sanitize it and call the upon sanitize attribute hook. But the fact is, because the attributes has been retrieved before iterating over the attributes, obviously, if you add an attribute within that loop, it won't be verified at all by DOMPurify. And if it's not being verified, it's not being verified by the regex, so you can like bypass it again.
Regex. Okay, gotcha. So what's happening here then is it's loading up a list of all the attributes first into like a local array, and then it's iterating across all of them, doing the sanitization. And then because you're adding things after that, it's not getting caught in that first, these are all the attributes for this specific node. And then Okay, I see what's happening here. Yep, that's buggy. But I wonder, you said this is something that maybe the folks over at Cure 53 can't resolve. But I'm thinking, what if just after the first iteration across all the then you'd have to do it recursively forever. Yeah. No, it's not going to happen. That's crazy. All right. So then you add another attribute. So any use of current node dot add, set attribute, or is there a way to add attribute here? Not that I see. I'm sure there is, but I guess set attribute could be used in the same way. Then, and you control any part of that, then you can trigger that same bypass.
That's it. And I've seen a lot of HTML editors that was simply like taking all the dangerous attribute that they do not know and like only setting a new attribute, which was prefixed with data. So that way they were sure that this was being safe, but simply because they were doing that, the whole sanitization was just broken.
Don't mess with DOMPurify, man. Like, don't try to make DOMPurify more secure. Like, they've got it. It's like shooting yourself in the foot. It's like rolling your own crypto. Okay, awesome. And yeah, here's that use of that same mutation XSS that we talked about before the call. Gotcha. And the thing is, I would like to go in, and we're already at like an hour, 15 minutes, which just blew by. So I'm not sure we're going to be able to get to the full research, explanation section this time around. But there are so many gadgets that I think are really helpful. You've mentioned two of them already. The fact that it parses the body, only the body, not the head of that DOM, and then the usage of how bypassing DOMPurify is very proceduralized with like the XSS or the mutation XSS being triggered via the title, style, or HTML comments tags. Those I think are really helpful. And I think you also included a section at the end of your article that talks a little bit about areas of research that can continue as well. So for anybody who's interested in continuing research or having a little bit more deep of understanding on how all this works, I'll refer you to mizu.re domain to sort of read through that. But let's go ahead and cover these remaining hooks. We'll dip into the miscellaneous section a little bit, and then we'll call it a wrap because we're already an hour 15 in. So let's talk about before SanitizeAttribute. So this is happening after the sanitization of elements. This is happening before the start of the attribute sanitization, and apparently, if there's some attribute manipulation happening here, that can result in a problem.
Well, manipulation can be like whatever you want. It could be a replacement, it could be a change. And if there is something like that, which happens on the ID attributes specifically, then you should be able to do some kind of second order DOM clobbering, which was a concept I have used in the first article. But basically, as you can see on the DOM Explorer window on the bottom, if there is a normalization like a trim or a replacement, you can have a form which has an ID with a value set to space X and an onload attribute. So at the time, DOMPurify is going to sanitize it and check for DOM clobbering issue. Because there is a space within the ID, DOMPurify will don't find any DOM clobbering issue, and the tag is going to be left. But at the time the normalization occurs in the before sanitize attributes, then you can recreate a link between the form tag and the input tag. So in that case, by removing the space. And because of that, you can now clobber the form tag before the attributes being retrieved. And thanks to that, you will be able to force DOMPurify to iterate not over the form attributes, but over the input attribute, the input tag.
Okay.
And
so,
that way, you just won't see the unload events.
Okay. So confusing. That's confusing. I'm sorry to take.
No, that's probably my fault.
But so what you're saying is, we've got a form ID space X, right? Then we got another input tag form equals X, right? So it's associating with that specific form. And so when the DOM Purify is reaching into the DOM to sanitize this attribute, I mean, it's not. I'm confused as to why this is resulting in because attributes. Okay, I see what's happening here. This is a little bit hard to explain. Yeah. Let's go back and explain that piece.
Maybe I should have explained the form attribute actually.
Okay.
So the form attribute can be used on input tags or select tags or whatever, which is related to a form. And that attribute is very interesting because it allows you to link your input tag to a form in which you aren't into. So this can be used in a lot of ways, but in the context of DOMPurify, what you can do is force this link to be created after the DOM clobbering check been made. So then, thanks to the normalization, the ID value and the form value will be equivalent, which will create a link between the form tag and the input tag. And at the time that link is being created, the DOM clobbering is going to occur. So now, thanks to this, you control the form.attributes value. And because DOMPurify is retrieving that value without doing any DOM clobbering checks, you kind of like break the sanitization for that form specifically. That
rocks, dude. That rocks so much. So what's happening here? Okay, this is like requires a little bit of pre-knowledge of DOM clobbering, right? And we typically, on this podcast, we try not to go back too far into the requisite knowledge that you need, because that gets a little cumbersome. But this time, I think it's helpful. So, in the DOM clobbering world, using a form and an associated input tag is a way for you to create to clobber attributes that are several elements deep. So X dot attributes in this specific scenario, right? But that only occurs if the input tag's form attribute is pointing to the ID of the form that it is being associated with, right? And so what's happening here is when that specific ID is being trimmed, right? That's what's happening in the code. And the ID goes from space X to just X. That is when it creates the link between the form and the input and allows us to override the attributes. Dude!
That's it.
Kevin, this is freaking genius, man. This is genius. Very cool. And the amount of detailed knowledge of the DOMPurify source code that is required for this is like really, really cool. How does let me ask you this, a little bit derailed, but how does DOMPurify deal with those DOM clobbering issues typically?
Actually, they are using a isValidAttributes function. I think that's the name.
Okay.
At the beginning of the SanitizeElement function, and in short, they check if the current node is a form, and if it is a form, it will check if, for example, the attribute value has a specific type, which is supposed to be a nodeName, I think, elements. If, for example, it check the nodeName, it will be sure that it is a string, etc. So it just verifies the type of all the dangerous attributes that can be present on a form. And if they find something malicious, they remove the form.
Kevin, dude, it's just unbelievable that I can just ask you about a specific section of the DOMPurify code and the procedure that they're using to sanitize, and just off the top of your head, you can rattle off how exactly they're doing that. That is unbelievable. This is what I'm talking about. Just a word to the listener really quick. This is what I'm talking about when I'm saying you should become the world expert on a specific piece of technology, right? Like when you're hacking something, you have to know it inside, outside, upside down. Even more so true if you're trying to bypass a security-oriented library like this. But even the applications that you face from day to day, the targets that you're going up against, you need to know that application inside, outside, upside down. So where you can rattle off the specific procedure that's used for whatever on that specific app. So this is a perfect example of that. All right.
And it even helps when you want to try to find bug while you aren't in front of your computer or your mobile phone, because you can simply think about everything that you have memorized and say, hey, there is something that I didn't expect, and now you want to try, but you can continue to think anytime. And
Yeah.
I think that makes the difference, actually.
Yeah, 100%, because it's all in there, right? And you can run simulations in your brain. You can be walking
Exactly.
down the street and be actively hacking. Like that's something that my wife and stuff doesn't understand sometimes, which is like, I'm sitting there, I'm playing piano, right? Like this desk right here that's behind me typically has a piano on it, like, you know, because I sometimes when I'm working and stuff, I gotta like get up and like play some piano or whatever, and I'm sitting there playing the piano and I'm thinking about where I am in the code base and where the flow of data looks like and what access to inputs and outputs I've got, and it just, you know, you can hack whenever, wherever. That's a great point, Kevin. Gosh, guys, I don't know. Podcasts like these just get me so jazzed up about bug bounty. Like, what a dream career we have, guys, where we get to just hack stuff every day. I love it. All right, rant over. Let's talk about after SanitizeAttribute and then some string replacement or attribute manipulation. What is this one, Kevin?
So this one is mostly the same as we have seen with the TinyMC issue and the jQuery issue. Like if there is any kind of manipulation or replacement occurring in the after SanitizeAttribute hook, because it happens after the regex checks being made, any manipulation can be dangerous, actually. So I'm just providing a first example, which is just a replacement to empty. But this could be anything that modify the value, actually. I think the second example is more interesting, like the two uppercase.
The second example is super interesting. I love this. and I love it when the stars align for stuff like this. So
yeah,
let's get to that. But first, the thing that you said was that if after SanitizeAttribute occurs, there is some modification to the attribute, right? After sanitization or modifying, that's where we kind of get into the issues like we talked about before. Specifically, this happens when you are replacing something to nothing, because you can create structures that shouldn't have been allowed to exist during the sanitization. Cool. Now, this is the crazy shit right here. Take it away, Kevin.
So this is something I don't know if it's well known, but when you are using the two uppercase method or the two lowercase in every language, it's not related to JavaScript. There is some Unicode normalization that occurs. So there is few chars which are going to be converted to the ASCII equivalents. And in those chars, luckily, there is one which converts a Unicode char to ST. So thanks to this, if the attribute is being to uppercase, you can like hide a style tag from the regex, which is going to then be converted to the ASCII equivalents because of that normalization. Dude,
that is just, I want to know what the code point for this is. Okay, it's Unicode code point 009C that gets like normalized to an ST when it goes to uppercase. And I think there's another one here too. There's two that kind of, when they go to uppercase, convert to ST. What a gift from heaven that is, right? Like that we have out of these, like, what is there, like 10, 15 characters that actually convert to something, completely different when they are uppercased. One of them goes to ST, which is exactly what we need for a style tag. Oh my gosh, dude. That's amazing. Okay, so then somebody's just simply doing an innocent to uppercase on the contents of this attribute. And we can use that to bypass DOMPurify by creating a style attribute, which is one of those ones that we're not allowed to have in the attribute. Is that right?
Exactly.
Man, the hits keep coming, man. That is very cool. And yeah, I think for anybody who is listening to the podcast and didn't know about this up to uppercase thing, one, you should either go back and listen to the podcast that you haven't listened to where we've talked about this, or you should try to take this opportunity right now in this moment to remember that forever, because that is extremely helpful in so many scenarios, this Unicode normalization. And this alone can really result in some crazy bounties. Being able to do this in a email or like a username or something like that can allow you to just get ATO super easy. So Unicode normalization is definitely something that any serious hacker web hacker in particular should look into, I think. All right, node manipulation, insert before. What is this one?
So this one is mostly related to the flow DOMPurify apply to sanitize an HTML input. So as we said, it will like iterate over the DOM from the toppest node to the bottomest one.
Right.
Yeah.
Yep.
And so if within any hooks, the developer decides to take a node and insert it above the current node, then this is something that DOMPurify won't be able to see at all because it's going to continue downwards.
Right. Okay. So if it has a reference to a specific div or something like that that's above it, maybe by an ID, and you just say insert before that, boom, we've now jumped in, effectively hidden that node from DOMPurify, so it can't be sanitized.
And this can bypass DOMPurify in many ways because imagine that this happens, I don't know, in the sanitize element function, and the inserted node isn't dangerous at all. Like it's just a simple p tag that you control, but that p tag has the regex bypass. Then it's enough to bypass DOMPurify.
Dude, it's crazy to see. It's crazy like to look at this example here and just see like the DOMPurify output in DOM Explorer just be a perfect XSS tag. Yeah, that's crazy.
And like you can play with the integration actually. If you want to update it in the bar, it's actually working in live.
Dude, that freaking DOM Explorer is so cool, dude. I love it. I love that. Very cool. All right, cool. So we got to keep in mind the order of the sanitization that's occurring. And if there's any elements being inserted into a node that has already been sanitized, then that is not going to get touched at all. That makes sense. Easy peasy. Let me see how many more of these we've got left here.
Maybe the node name normalization is interesting.
Node name case confusion, is that the one?
Not the base href pollution. This one is very technical, very deep, but the impact is not that much useful.
And we sort of already talked about it, right? This is using the base tag to affect the fully qualified URLs of the items, of the relative URLs in the body of the DOM that is parsed by DOMPurify, right?
Yes, but not only. There is also the fact that I'm abusing that DOMPurify is streaming all the attribute values to have like some collision between what it is going to use and what the DOM is going to receive. But in the end, this is it. You have a way to control the final href, which is going to be sanitized within a hook.
Wow. Damn it, Kevin. All right. Fine. We'll have to come back to that. That one is very, very technical. I do love the output of it, though. This is just a beautiful exploit. So we're gonna leave that one to the listeners to go check out themselves, and then we'll talk about this one. This one is node name namespace case confusion. Is that the one you wanted to talk about?
Yes, because I think that one is pretty common. Like I've seen it a lot of time in bug bounty. It might sound a bit stupid, but when you try to access the node name value, depending on the namespace of the node on which you're trying to retrieve that value, the case is going to be different. Like if you try to access node name in the HTML namespace, it's going to be uppercase. But if you try to do the same within the HVG namespace, it's going to be lowercase.
Why?
I don't know.
That's crazy. Is that something specifically done by DOMPurify, or is that a part of the like HTML spec?
It's part of the HTML specification. Like this is something that browsers do.
Node, yeah, of course. Node name. Okay, current node. We're using the browser 8. Wow. Okay, so that's weird. So if we hit node name, typically, in the HTML namespace, it's going to be uppercase. But if it is in the SVG namespace, then it's going to be lowercase.
Exactly. And
interesting.
I've seen some application using that specifically to sanitize style tag, for example. So to sanitize the content and limit what the user can do. You actually sent me an example right after reading the article, but
Yeah.
this is something very common. And by simply putting your style tag within the SVG tag, in case it do not check it with to uppercase, then you will just bypass this condition and we're able to do a full CSS exfiltration.
Wow. Okay. So, and that output there that has SVG tag style inside of it, that's perfectly valid HTML
yes,
style tag that will execute on the page. Having it wrapped inside of an SVG doesn't like hijack the functionality of it at all.
I'm sorry, I'm not sure to have understood the question.
That's fine. So, the output here of the sanitization that you showed is SVG and then a style tag, right? So the style tag is wrapped in the SVG. Yep. But that doesn't affect the functionality of the style tag at all. The style tag still works normally on the on the page. Wow. Very cool. Very cool. Okay. Do you want to cover this last one? I know that this is like a DOM clobbering DOS, but I actually let's do it if we can, because I think this you made a great point that DOM clobbering inside of an HTML parser like this or sanitizer can have really bad effects on applications.
Yes. So this, I think this kind of exploitation is still very specific. Like if you're trying to DOS DOMPurify or any JavaScript library in a page that isn't visited at all, it might be useless. But if you manage to use DOM clobbering to like DOS DOMPurify within the chats, then you will be able to block the conversation for all the user, which is way more impactful.
Very impactful.
And when you are using as a developer before sanitize elements in DOMPurify, this specific hook occurs before the DOM clobbering check have been made. So if like the developer use any attributes function of a node, then you can simply clobber it on a form and DOMPurify is going to crash.
Okay, so it will, if there's anything being done before sanitize elements, then that is before the DOM clobbering check. So you can just blow it up essentially. Yep. Wow. Okay. That seems like a problem. Yeah. I wonder why they didn't move the DOM clobbering check to before. Well,
it's complicated because they want the developer to be able to manipulate the node before it's being sanitized by DOMPurify. So I'm not really sure there is something they can do about that.
Yeah, I agree. Okay. Let's jump into the miscellaneous category here. The regex this is the regex, by the way, for everybody. We've been alluding to I don't know that I've showed it on the screen yet. My bad. This is the regex that everybody needs to know. And I'm sorry for people that are audio only. You're screwed this time. I'm not going to read a regex out loud to you. But the code that uses this regex is actually prefixed by an if statement. And the if statement says if say for HTML and regex test, right? And then goes through our regex. So you say, of course, if this is false, then we trigger the bypass. So when is that a specific configuration that can be passed in?
Yes, actually, I've seen it recently with a friend in Bug Bounty, where in a library the developer was like using it because he wasn't able to use comments within attributes. So when I first see it, I was like, okay, that seems legit, but you're just breaking the whole DOMPurify sanitization. And this is something that is mentioned in the DOMPurify README. But if the developer doesn't take it into account the fact that there is a warning about it, then you can bypass it easily.
Very cool, man. Very cool. So if they pass in say for XML set to false, then it's just boom, game over. You're done.
Exactly.
Okay. There are a lot of other really cool things in here.
Yep.
I'm going to do these two. I know I said that I was going to be done, but I'm actually not going to be done. Suck it, listeners. You better keep listening because this is cool shit. Okay. So, all right, this is it though. After this, I'll end it. I know we're going long. This misconfiguration is really, really cool. And this switches back over to the server side, right? This in the scenario where we are in the server side. And what's being done is that there's a JS DOM is being used with DOMPurify. And JS DOM is the recommended server side parser for this to be used in conjunction with DOMPurify. But dude, this is like really gold. If there is no content type char set defined, right? If there's no char set defined for that specific DOM, which I would imagine would happen all the time, if people are just on the fly sanitizing HTML, they're not going to set like a content type header or whatever. Then this would be resulting in a full bypass using that sort of what is the name of that research that came from SCRHY here? Let me see. It's encoding
some
differentials. Why
that
char
have
sets
been made by
matters.
Sona. But
Am I tripping
something
here?
fun about that research is that this is something I have found like 1 month before Sona released everything. I have reported that to DOMPurify, and Cure53 told me that this is not something that they could fix. This is something that had to be reported to Google. And actually, I was just thinking that this is not something that was going to be found quickly by someone else. So I decided to play a bit with it in Bug Bounty, and like something a month ago, I see the whole research here, and I was like, okay, great, but unfortunately.
So you had it before research collision. Of course, it happens.
Yeah.
But what this, if I understand correctly, this is that same research as well that was talking about how you can use like one of the Japanese character sets to trigger. Is that accurate? Right? Where
that's one, yes.
It will
ISOGP 2022.
Right. Okay. So what you're doing here is you are manipulating the fact that there's no char set on the server side, and then using that fact to make the browser sniff the char set. And since DOMPurify isn't aware of that, then in JS DOM, then it will bypass it. Is that accurate?
That's it.
Wow, dude. Yeah. Like, am I crazy to think that this is going to be like super common, a super common bypass? I can't imagine somebody setting a char set like that.
Like a lot of framework by default set a char set nowadays. I think where it's going to be the more present is in file uploads. Like if you can upload, for example, an SVG and it's being sanitized, most of the framework, when they do send the file, they won't set the char sets. So this should be vulnerable all the time.
Kevin, I'm misunderstanding what's happening here. The problem is not with. So we also have to have a char set not defined at when it hits the sink on the client side. Is that accurate? Or no?
Not really. It's like when the browser is like loading the page, it do need to not have a char set being defined.
The browser, the final rendering of the payload?
No, I mean the HTTP response in the content type response header. It do need to not have a char set for it to be sniffed.
Right. But what I'm wondering here is whether we can take. So there's two things happening here, right? It's creating a JS DOM, right? And then it loads that into DOMPurify, and then it runs DOMPurify sanitize on that specific string, right? And that specific string has the stuff to indicate that it's the Japanese character set, and then renders it, and then the output of that, does that also need to not have a character set, or can it just can it be integrated into a UTF-8 character set and it's fine?
It's fine. It's like I think it's the like escape chars, which is a basic ASCII character that you need to use to trigger the cut point to switch between the Japanese chars and the ASCII one. Okay. So this is something that is going to be allowed most of the time by any text parser or sanitizer like DOMPurify. Okay.
So I'm looking at this code right here. This you set the header text HTML here. Could this have the UTF-8 character set in it, or is that necessary to not have that?
It's not mandatory, but nowadays almost every frameworks to have it set by default. So
right. So if it did have it, would this clean not work, or would it still work?
It won't work, but there is still some tricks that can be made. Like even if the content type is set to text HTML semicolon char set is equal UTF-8.
Yeah.
UTF-8.
Yeah.
Excuse me.
You're good.
There is something fun is that if somehow you can control the 2 first bytes of the response, you can use the BOM characters to specify the browser to parse it as UTF-16. And even if the char set is defined as UTF-8, it still will work. So it could be possible to be bypassed that way, but DOMPurify do not allow us to use
Those characters. Okay.
those characters.
Okay. So I guess my question is this. Right here on this line where it says clean equals DOMPurify.sanitize and then passes in our specific input, will the output of clean after this is done, when passed to a specific or when passed to like a normal browser DOM with text HTML,
okay.
UTF-8,
I get the question.
Will that trigger an XSS, or does the end browser also have to have a no char set defined?
Good question. Well, that depends on the actual library that you are using. In the context of DOMPurify, it's JSDOM, and by default, it do not execute JavaScript. So even if there is a way for you to trigger JavaScript within DOMPurify, it won't be executed at all, only because this is disabled by default.
Okay. Gotcha.
But if you're using, for example, a library like HappyDOM, which is present right at the bottom, this is something that can happen.
Okay. So they say use JSDOM, but if you're using something else like HappyDOM, then you can trigger JS execution inside of DOMPurify sanitization.
Yes, and actually this isn't how do I manage to get an RCE, because obviously the JavaScript execution occurs within the sandbox, so you can't really escape it. But the fun fact was that when you provide to that parsing library scripts with a specific source, it's going to use a sub-process using node-e to fetch the file, retrieve it, execute it, and the link that is provided within script source is single quoted. And why this is bad?
Nuts.
Because within the pass and within the anchor, you can put single quotes which won't be encoded by default within the URL hierarchy. So that way, I was just able to hide Node.js code directly within my script source. So you should be able to see it in the second snippet.
Yeah, right here.
Which are going to be executed directly within the library.
That's crazy. It's like that old Flash thing. This is what we always reference in these sort of scenarios, where the way that you used to trigger Flash-based XSS a lot of times was you could just close off it would just dump it right into a JS eval, and you could just close off all the functions and stuff. That's crazy that this is happening with HappyDOM as well. And
this is something I've found a lot in Bug Bounty. Sometimes the developers simply reflect the current path within a JavaScript variable. But if you do that with a single quoted string, you can just escape it using a single quotes. It's not encoded.
Wow, that's nuts, dude. How do you? I guess then we go back to the fingerprinting problem. How do you figure out, if they're doing it server side, what DOM parsing they're using, like HappyDOM versus JSDOM? That gets a little trickier, right?
Maybe if you create a local setup and you try to see some differences between the HTML parsing, you will be able to find something.
I feel like there's some stuff out there for that.
Yeah.
All right, Kevin, we are an hour, 45 minutes in. This is you right here. I have squeezed you for every last bit of wisdom that I can get on DOMPurify, at least the second article. And we still didn't even get into the first article. So thank you so much for coming on, for sharing so willingly about all of this research that you've done. Really, really appreciate it. This is really a masterclass on DOMPurify. Anything you want to say or anything you want to shout before we wrap this pod?
That's right. It was a pleasure for being there. It was amazing speaking about DOMPurify today. And yeah, I think that's all. I'm awesome. Very happy being there.
Thank you so much, Kevin. Appreciate you, brother. Peace. And that's a wrap on this episode of Critical Thinking. Thanks so much for listening. And if you want more critical thinking content, head over to ctbb.show/Discord. Join the Discord. There's lots of great conversations and chats going on over there. And if you want to support the show, there's the Discord subscriber tiers, which give you access to masterclasses, AMAs, hackalongs, exclusive scripts, and an exclusive chat channel with us. We'll see you there.